In our next lesson for the IB Mathematics standard level, we'll talk about quadratic equations. This is essential, very essential knowledge in this course. So we can start. The general form of any quadratic function or equation is I have f of x is equal to ax squared plus bx plus c, where a and b and c are constants to be found. What we have to know about this function are these main things. We have to know the first thing, we have to know the shape of the function. The second thing, we have to know the y-intercept. We have to know, this is the second. The third thing we have to know are the x-intercepts. We need to know the vertex and axis of symmetry. Let's start with the shape. Let's start with number 1, the shape of our curve. The shape of our curve has two cases, depending on the value of a. If a was negative, which is less than 0, then the function is concaved down. Concaved down. If a is positive, which means a is greater than 0, then the function is concaved up. This is for the shape. Number 2, we'll take the y-intercept. How can we find the y-intercept? We always find the y-intercept is when x is equal to 0. So to find the y-intercept, simply I need to find f of 0, or substitute in the function x equal to 0. If we substitute f of 0, then we have a times 0 squared plus b times 0 plus c, giving us c as the y-intercept. This is our y-intercept. I hope it's clear till now. Now let's talk about finding the x-intercepts. The third part is the x-intercept. We find the x-intercept when y is equal to 0, or the whole function is equal to 0, which is the same. We can take an example for finding the x-intercept. If we have f of x is equal to x squared minus x minus 2. So here, to find the x-intercepts, or we call them the roots, we need to substitute instead of the f of x is 0. So we'll say that x squared minus x minus 2 is equal to 0. We factorize x minus 2, x plus 1 is equal to 0, having an x equal to 2, and x equal to minus 1. So here I'm having the x-intercepts are 2 and 0 with minus 1 and 0. And we call these roots. We call them roots. Roots, it means where the curve crosses the x-axis. This is how we can find the x-intercepts or the roots. To know how many roots a function has, we need to calculate the discriminant. We need to know the discriminant. The discriminant, we write it as a triangle is equal to b squared minus 4 times a times c. If the discriminant is positive, then the function has two different roots. As if we have x minus a times x minus b is equal to 0. So x1 is equal to a and the second root is b. The second case, if the discriminant is equal to 0. If the discriminant is equal to 0, then we have two repeated roots. As we have x minus a times x minus a is equal to 0. So x1 is equal to a and x2 is equal to a. We have two same roots, which is one answer, but we call it two repeated roots because quadratics is either we have two different roots, two repeated roots, or we have no roots. So which is the third case, I'm having the discriminant is negative, which is less than 0. Here we have no real roots, which means I have no intersection on the x-axis. This is for the discriminant and how to know our number of solutions, which are the roots. It is so essential in the IB. Many questions come on the discriminant. We have always to use the discriminant if the question says that if certain function has two different roots or has only one root or has two repeated roots, we have to use the discriminant to solve this question. This part is so important. Now, we've covered the shape, the y-intercept, and we've talking about the roots, which are the x-intercepts. Now we can talk about the vertex. The fourth thing to know, and it's so important, is the vertex. We have three ways to find the vertex. The first way is that the x-coordinate of the vertex is equal to minus b over 2a. This is the x-coordinate of the vertex, which is minus b over 2a. Let's take an example of a function. Let's take this function we considered before, f of x equals x squared minus x minus 2. As this one, x squared minus x minus 2. If we want to find the x-coordinate of the vertex, simply we have to use minus b over 2a. Here we have b is minus 1 and a is minus 2. So the vertex here is minus the minus 1 over 2 times 1, which is the coefficient of x squared. So the x-coordinate of the vertex is half. To find the y-coordinate of the vertex, we have to apply it in the function, which is f of half, which is equal to half squared minus half minus 2. No need for a GDC for this question. So we can use it's 1 over 4 minus 1 over 2 minus 2. 1 over 4 is the same as, this is 2 over 4. We'll have minus 1 over 4 minus 2, which is equal to minus, this is 1 over 4, and the minus 2 is 8 over 4. We have minus 9 over 4. So my coordinate of the vertex here is half with minus 9 over 4. This is my vertex. The second way to find the vertex is that the x coordinate is equal to root 1 plus root 2 divided by 2. Root 1 plus root 2 divided by 2. We can get back to our roots. We have a 2 as a root and a minus 1 as a root. So it's simple as 2 plus the minus 1 over 2. We have, it's 1 over 2. And to find the y coordinate, it's simply f of half. These are the first two ways. Either you can use this one, or if you have the roots, it's easier to use this one. The third way, which is so important and essential, is to write the equation in the vertex form. In the vertex form, which means f of x must be written in this form: x minus h squared, here we have a as a constant, plus k. After writing the function in this form, I can know my vertex coordinate with the x coordinate as h and the y coordinate as k. How can we write it in this form? We use completing the square method. Now let's do completing the square, and we check if we have the vertex as this one. Again, to our function, we have f of x is equal to x squared minus x minus 2. The first thing in completing the square, we have to make sure that the coefficient of x squared is 1. Otherwise, we have to take the coefficient of x squared as a common factor to make it a 1. Let's continue. We have x squared minus x minus 2. Now, we open a bracket. We take the x squared and make it as x. We have, this is minus 1. We take this minus 1 and we divide it over 2. So it becomes minus 1 over 2. And then always we take this negative outside the bracket. We take it always negative. We keep, this is always negative. This sign is always negative. And we take this value and we square it. Negative 1 over 2 squared. And also simply we take this minus 2 as it is down here. This minus 2. So I'm having now my f of x written in this form. We can continue. It's f of x is equal to x, here squared, I'm sorry. X minus half squared minus half squared is 1 over 4 minus the 2, giving me f of x equal to x minus half squared minus 1 over 2 minus the 2 is minus 9 over 4. So now I can simply find my vertex. This is a minus. I take it as opposite side, opposite sign. So it becomes half. With, I take this as it is with minus 9/4. This is my vertex. I found my vertex by completing the square or writing the function in the vertex form. This is the vertex form. We call it the vertex form. As you can see, it's the same as our vertex here. These are the most things you need to know about quadratic equations. Practice is essential. It's essential to know the shape, how to find the y-intercept, the roots, and the nature of the roots. And you have two roots, or you have repeated roots, which is one root, or no roots. And it's important to find the vertex as well. Now, for our last thing we want to talk about is, we've covered the vertex. Now we'll go to our axis of symmetry. Axis of symmetry, this is number 5. Axis of symmetry. Axis of symmetry is the equation of the line that cuts the function in half. This is the axis of symmetry. X equals, let's say, A. The equation of the axis of symmetry is the same as the x coordinate of the vertex. X coordinate of the vertex. As simple as this. By now we've covered all the main parts for a quadratic function. Now we're going to solve an example, which is a question taken from the question bank. I have f of x equals x squared minus 4x plus 5. The function can be also expressed in the form of x equals x minus h squared plus k, this is the vertex form. This form is the vertex form. Part A of the question needs to find the equation of the axis of symmetry of the graph of f. The equation of the axis of symmetry. Axis of symmetry, we can find it as, it's the same as the x coordinate of the vertex, so we can use x equals minus b over 2a, which is equal, b is minus 4, so is minus the minus 4 over 2 times a, which is 1, which is equal to 4 over 2, which is equal to 2. So the equation of the axis of symmetry, x is equal to 2. Let's go for part B. Part B, we need to write down the value of h and the value of k. So we need to take this function and simply do completing square method. So it becomes f of x is equal to x, and we divide the minus 4 over 2, so it becomes minus 2, all of it squared, and we take the minus outside, and with the 2 we square it, and we take the plus 5 as it is. So it becomes x minus 2 squared minus 4 plus 5, which is plus 1. So simply the value of h is equal to 2 and the value of k is equal to 1, which is the vertex is 2 with 1. And by this we've covered the most important parts of the quadratic equations. You need much more practice, because where you have to, if you want to do or to get great marks in math, you need much practice and very good practice.